Hi, this is Alexei. Let's go over key improvements in Rapise version 6.2 from Inflectra. Rapise 6.2 is a faster and more efficient way to service your tests. With the new self-healing feature, we can automatically restore most web object locators when an application is changed. We see areas where maintainability is limited in all available solutions on the market. Once you deal with Appium or WebDriver with an open source or commercial solution, you will spend a lot of time waiting for WebDriver to launch a browser or an application. We managed to avoid such time losses for mobile applications. Let's take a closer look. Self-healing is a way for recovering objects when application user interface is changed. Rapise now may automatically do recovery and update object repository. Here is an example of Rapise self-healing in action. We have an application written in Angular. We have a test in Rapise which is passing, and it's recorded against this version of application. It has been recorded with AI enabled as according to the documentation topic. So there is a topic self-healing with Rapise, and we use this piece of code and put it into our script when recorded it. So now this test is ready for self-healing. What I'm going to do, I'm going to add one more step to this test and navigate to different entry point, to different version of this application. So I'm adding navigate to the React version, as you may see in the URL, and let's see how it works. So I'm just playing it. The test is executed with Firefox, so it's just navigated to React entry point, puts username, password, and finally does a logout. After test has been executed, and you see it has been executed successfully because it was able to interact with controls and it didn't fail, we see the prompt saying that some object has been changed and were recovered during the execution. And if I say yes, it shows me which objects has been changed, and I may investigate what has been changed. In this case, XPath changed for each object. And if I just press copy all to destination, it will update the test. So next time self-recovery is not needed unless application has been changed again. Here in the report, I see self-healing report. So in the case object has not been found and were recovered, I may see this recovery log and detailed information about old object, new object, and a corresponding screenshot. So this gives additional information about what has been changed. If I just play this test again, since I updated object, it will run without self-healing until something changed again with the test that breaks the compatibility. In this case, self-healing will be automatically enabled again and will recover your object. This is intended to save you time to maintain your test. Connection to browser is something taking time. WebSpy takes additional time because it builds its own comprehensive DOM tree representation. Now it's done faster because it's done only once. You make check and recover many objects in one WebSpy run. Rapise Spy has new maintenance mode. Maintenance mode shows up automatically when you launch Spy right from Rapise. Spy shows up, and difference from earlier mode is the presence of the object tree on the right. You may quickly check presence of any object on the screen. So if I hit on something and see this red icon, it means that object is not found on the current screen. I may check objects one by one, or by double-clicking on the window title. So now I can see that one of three objects is found, and if I click on it, it gets highlighted and it has green mark, while these two are broken. Since I can see them on the screen, then the problem is with object locators. Something has changed, and I am going to quickly fix this. This is another feature of the maintenance mode. So I'm selecting object, and you may see that relearn object appears. But before pressing it, I need to locate the object either in the object tree or on the screen. For locating it on the screen, I'm hitting Track or Control T, selecting object and hitting Control T again. So object gets selected in the DOM tree. And now I hit Relearn and object gets fixed. I may quickly do the same with username, Control T, locate object, Control T, Relearn. So this is much faster way than before, and you may quickly fix objects and check if they are all available on the screen. You see, all of them get highlighted one by one, and all of them get green check marks, meaning that they are found. That's a maintenance mode. You may hide this panel if you don't need it, if you don't want to use maintenance mode in current session. Let me click it up. Here it is. Reconnection is even more important for mobile apps. Default behavior of Appium is to always reload application when connecting and terminating it when test execution fails or stuck. Connection to mobile app is a slow process. Also, you have to navigate to required screen within an application to do maintenance activities. We've changed this to save time and effort by avoiding reconnect, restart, and navigation of application when possible. Here we have a mobile test. We are executing it. The test starts, it's doing something, but then it breaks due to absent edit username object. We start mobile spy in the maintenance mode. Select this object in the object tree. Red mark means it's not found. Find object on the screen and click Relearn to fix. Green mark means it's found. So we fixed it. Now application keeps running, so we may just play the test from the point where it stopped. And it works. Thanks to Appium and Rapise, you can execute web tests right on your mobile device. For longer tests, it's important to reconnect to the application when the test is interrupted and fix it. Sometimes you need to quickly try some middle step, fix it, and try again until you get the perfect result. In this example, we have a web test running on the mobile device. We start its execution. Appium connects to device. Device starts browser. Browser goes to initial URL. And then script fails because the object username is not found. We're going to fix it. We use WebSpy in the maintenance mode. In maintenance mode, we have object tree on the right. We may check the object username and make sure it's not found. So it's time to fix it. In this case, we do it directly by changing its XPath. Now we can test. Okay, something found. We may even highlight it. Okay, it's highlighted on the screen. And we may use relearn feature to fix the object in the object tree. Okay, it's relearned, so it's fixed. We may close the spy, and now we may proceed the test script execution from the point where it gets broken by using play from here, the feature of RVL. The script plays from this point without reconnecting to application, without restarting session, and everything is passed. It is always convenient to be able to record and execute parts of the test script in small portions. It was difficult to do it with Appium. The session and application are restarted every time you connect to the device, but it's no longer a problem with Rapise 6.2. Let's record the test in two portions. We start Mobile Spy, attach to the application, and now you see how long it takes to initiate the first Appium session, to start an application, and to connect to it. It really takes significant time, and this is what we want to avoid. So we do it only once when we connect first time to the application. That's it. We have it. The spy reads information. We select existing session. So we attached. We select element, tap on it, and this way the action is recorded. So we have first portion of the script with one step. Now suppose we want to record more. We run the spy again. It attaches to the same session in the application, so we keep working with it. And we insert script steps. So we enter in username, password, and tap the login button. So we have 3 more steps now. Done. We append additional 3 steps here.